Question 5 and 7b, we have a particle of mass m moving with constant speed in a horizontal circle, which is on the inside surface of a smooth sphere, the radius of which is 13. So the center of circle of motion is 5 meters below the center of the sphere. So our diagram is, we'll call this P. If it's 13, the radius, so it's 13 from the center of the circle to the edge of the radius, or the edge of the sphere, and then it's 5 meters below the center. So by Pythagoras, this one is 12. We have A. Do our angles first. Cos A is 12 over 13. So T cos A, tension in the string, is equal to 12T over 13. And T sine A, you can see it's going to be 5 over 13, 5T over 13. And coming down in kilograms, we have just M, so mg coming down. Because it's a smooth sphere, we have no reaction in this direction. But we do have this here, which is our T sine A, 5T over 13. So 5T over 13 will be equal to my mg. So my tension multiplied by 13 and divided by 5, tension is going to be 13 mg over 5. And then we're asked to show speed, so we're dealing with V. So mv squared over r is the central force, centripetal force. So we are asked to show that it's 16.8. Okay, well we have in this direction, we have the 12T over 13. So 12 over 13 by T is going to be 13 mg over 5, 13 mg over 5. So the 13's cancel. So my force going towards the center is equal to 12 mg over 5. And this will be equal to mv squared over r. And we have r is this radius down here, the radius of motion, which is 12. So we can divide by m, so we're going to get 144g. 144g over 5 is equal to v squared, and hopefully the square root of this is 16.8. 144g over 5, typing into a calculator does give v to be 16.8 meters a second. Question 5. Question 6, we have a conical pendulum consisting of mass m at the end of a piece of string. It's 1 meter long, so set up my diagram here. It's 1 meter long, 1 meter, and we have mg. So what's happening here? It's fixed to a point of the ceiling we call P. The particle is made to rotate in a horizontal circle. We can't show the rotation, maybe something like this in a horizontal circle. And the string makes an angle of 30 with the ceiling, so 30 here, we'd have 60 down here. So because the hypotenuse is 1, this side is going to be cos of 60 will be equal to, we'll call this x and y maybe just in this question. Cos of 60 is equal to x over 1. So x is equal to the cos of 60, which is 0.5. And y is equal to, similarly, the sine of 60, which is equal to root 3 over 2. In terms of t then, tension in the string, we will have root 3 over 2 t in the opposite direction, and the adjacent direction we'll have just t over 2 or 0.5t, whichever way you want to set it up. So that's my force going in that direction and in that direction. It's just hanging, so we've no r here. It's not touching off or sitting on a table. Find the tension in the string in terms of m and g. Okay, well, let's look at our forces going up. Root 3t over 2 will be equal to the opposing force going down, which is equal to mg. So T is going to be 2 mg divided by root 3. 2 mg over root 3. And the constant angular speed, so in this direction, angular speed is mw squared, or so we have t over 2 in that direction. T over 2 is equal to mw squared over r. So if I divide this one by 2, the 2's will cancel, so t over 2 is just going to be mg over root 3 will be equal to mw squared r divided by m, and my radius is the x, which is 0.5, so I'll just change r to 0.5. So I'd have to multiply by 2 to get rid of the 0.5, multiply both sides by 2, I'm going to get 2g over root 3 is equal to w squared, so w is equal to the square root of 2g over root 3, and that works out to be, the squared part works out to be 11.316, so if I get the square root of that, I get 3.364. 3.364 radians every second. 3 decimal places is what they're looking for. In question 7, we have a marble of mass 10 kilograms, describing a horizontal circle on a smooth inside surface of a sphere. So again, no or here, so we have a fixed point. We have the length of the string and the radius of the sphere, which is the length of the string, 1.3. My circular motion in this direction. My or, and we're told the radius here and the center is 0.5 meters below the center, 0.5. So this is my 13, 5, 12 triangle. So the cos of A is equal to 12 over 13. So my force in terms of t in this direction is 12t over 13. Put my t in, and then sine A, which is going in this direction. Sine A is 5 over 13. So the force will be 5t over 13. Coming down, we have 10g, which is equal to 98 newtons. So straight away we can get t, we can say 5t over 13 is equal to 98. So 13 doesn't go into 98, I can get calculator use. 98 by 13 over 5 will be tension. So 98 over 13 times 5 is 254.8 is the tension in the string. The normal reaction, well, the normal reaction is this tension here in the string, and then the constant angular velocity w. So we have 12t over 13 and going towards the center, centripetal force, 12 over 13 times t. Well, actually I can see a 13 here, I'm going to put it back in this format. So times t is 98 by 13 over 5, just to make it a bit easier. So again, that doesn't work out evenly. 12 by 98 divided by 5. Well, let me see here, what does the right hand side become? M is 10 by w squared by the radius, which is r down here, which we got, it's going to be 12 but 1.2 with the decimals. 1.2. 10 by 1.2 is 12. Actually, when we divide by 12 and we get rid of both of these, so we have w squared is equal to 98 divided by 4, which is 19.6, and the square root of 19.6 is 4.427. Does it ask for decimals? Doesn't. I'll give it a 3 radians every second. Question 7.